Hello there, students. I hope you don't mind if I talk like this the whole time. Today we're going to be learning about linear inequalities. So, our objectives are your learning targets, and I'm going to draw a little target here. This is my target. Alright, there's my target. We're going to try and hit that target. Um, is to graph linear inequalities in two variables, as well as use linear inequalities when modeling real-world situations. So, let's start off with a couple of vocabulary terms. The first one is a linear inequality. A linear inequality in two variables such as... Alright, I'm done with that. Sorry about that. I hope it gave you a little bit of insight as to how I could talk every time, but I won't do that. We're going to continue with linear inequalities. A linear inequality in two variables, such as here's an example. It looks just like a linear equation, only it has an inequality symbol instead. Y is greater than x minus 3. It can be formed by replacing the equal sign in a linear equation with an inequality sign or symbol. There we go. The solution to an inequality in two variables is an ordered pair that makes the inequality true, just like as an equation would work. Although with inequalities there tends to be many solutions to it. Two things we're going to talk about today. We're going to identify solutions to linear equalities. We're going to graph linear equalities, and then we're going to finish it up with a challenge that has to do with real-world linear inequalities. So let's start off with identifying. So when you're identifying solutions, basically I'm going to give you an inequality, and I'm going to give you an ordered pair, and you have to tell me if it's a solution or not. And here's my only clue for you. Plug it in, plug it in. Freshness with a twist. Plug it in, plug it in. You know, like those commercials for Glade. Good stuff. We are going to plug things in. So here's your first two problems, really. But we're going to use that linear inequality. Y is greater than x minus 3. And I want you to tell me if each one is a solution or not. So we are going to plug it in, plug it in. We have our x value, we have our y value, and our linear inequality is y is greater than x minus 3. So we're going to plug in. 1 would go in for the x, 2 would go in for the y. You then have 2 is greater than 1 minus 3. 1 minus 3 is actually negative 2. So 2 is greater than negative 2. Is that true? Yes. So yes, it is a solution. So yes, 1 comma 2, that ordered pair is a solution since it worked out. All right, second one. Again, we're using the same linear inequality. Y is greater than x minus 3. And we just want to figure out if this is an ordered pair that would work. So we're going to plug in for the x. We're going to plug in for the y. You have negative 7 is greater than negative 3 minus 3. Okay, we know what negative 7 is. Negative 3 minus 3 is negative 6. So is negative 7 greater than negative 6? No. It might look like it because 7 is greater than 6, but negative 7 is actually farther in the negative, so it's not. No, so this is not a solution to this inequality. So this is really basically all you have to do for identifying solutions. You can take an ordered pair, you can plug it into an inequality, see if it works out. If it does, it's a solution. If it's not, it's not. So try this one. Well, we have two of them here. On your own. A says, is 3, 6 a solution to that inequality? Y is less than or equal to 2/3 x plus 4. And then B says, suppose an ordered pair is not a solution to that. Would it have to be, so Y is greater than or equal, sorry, greater than x plus 10. Must it be a solution to Y is less than x plus 10 then? We'll come back to those at the end, and you can see how we answer those. So continuing on, we're going to now talk about how we graph linear inequalities. All right? We are actually going to, so I got a couple pointers here for you. It's very similar to graphing a linear equation. So y equals mx plus b, if it's in that form, which you should try to get it in that form, where m M is the slope, because M stands for mountain. Here's a good hint. M stands for mountain. Mountain has slope, and so M is the slope. Ain't that dope? All right. M stands for slope. I just made up that little rap there all by myself. Anyway, B is our y-intercept. That's where it crosses the y-axis, if you remember that. All right. Here's another tip. When you're making the line, it's different if it's dashed line or solid line. So this is where so if it's less than or greater than, it's just the dashed line. So we'd make a line that's dashed with our arrows at the end. If it is greater than or equal to or less than or equal to, that's where it's a solid line because it could be equal to that line. All right. And last thing, shading. So when you graph this line, you also have to shade a part of it. So let's say this is our line. And if it is greater or greater than or equal to, we'd shade up on top of it. If it was less or less than or equal to, we'd be shading on the bottom of it. Okay, you're always only shading one part though. That means all the ordered pairs, if it was greater than, all the ordered pairs that would work for this inequality would be above it, over there, and vice versa. So let's show an example of that. Oops. So, what is, well, I have two of them here. Let's just slide this down a little bit. So, what is the graph of y is greater than x minus 2? All right. Well, let's identify the slope. The slope is, there's nothing here, so it's just 1 over 1. Rise over run would be 1 over 1. The y-intercept is right there. It's negative 2. So we're going to start the line at negative 2 on the y-axis. Going to go up 1 and over 1, up 1 and over 1, up 1 and over 1. So we've got it a line. Now we look at the symbol. It's greater than, not greater than or equal to, so that makes it a dashed line. Just use that checklist, those things that I did right here, up on top. Dashed line, and now shading, if it's greater than, that's a greater than symbol, we'd shade everything above that line. All right, and that is how you graph an inequality. Try this one on your own real quick. It says, what is the graph of that inequality? All right, I'm going to actually erase this, and I'll come back to this in a second for how you would do that. How you do the next one. Oh, it doesn't work. All right. Second part with the graphing I wanted to show you was graphing a linear inequality with just one variable. So these are those interesting ones. You got to remember if they're vertical or horizontal lines. So if it says x is greater than negative 1, remember if it was x equals negative 1, you go to the negative 1 on the x part. So we're going to do this one right now. And we go opposite of the x-axis because this is the x-axis, this is the y. So we're going to go like this. But I'm going to erase that because if you look at the symbol, it is a greater than symbol. And a greater than symbol has to be dashed. Now the question is, we don't have an above or below part for this. That was a really bad dash. So, you think about the x's. If it's anything greater than negative 1, you go on the x-axis, and numbers greater than negative 1 would be all over here. Alright, so it's a dashed line shaded to the right. Now, I'm going to do this one in green. Y is greater than or equal to negative 2, or positive 2. So I'm going to go up positive 2 here. It might be hard to see. And it is or equal to, so it's going to be a solid line. Hopefully you can make a straighter line than me. And it says greater than or equal to, so it needs to be greater than or equal to. Now, the reason I put them both on the same graph is to show you that when we get to systems of inequalities, which is next, when you have two inequalities, you graph them both, and whatever part they're both shaded in, which is just this section right here, that would be the part where the solutions could be. All right? And And before we go to the final question, I want to go back and show you the answers to what we just did. So the first part, identifying. This got it question. First said, is 3/6, so we're doing right here, is 3/6 a solution? So what I did was plugged in x for the x, y for the y, and they ended up being equal. And yes, it would work because it says less than or equal, so that is the or equal part. B says, suppose an ordered pair is not part of y is greater than x plus 10. Would it have to be part of the inequality y is less than x plus 10 then? And the answer is no, because what if y is equal to 10 plus, or x plus 10? That would be the only other case that it could be. So it doesn't necessarily have to be part of that equation. All right, and then the got it question for the graphing part. I graphed this one right here. So I did, the slope is, or the starting point is 1, that's the y-intercept. Slope is up 1 and over 2, and it's a less than or equal to, so it's a solid line and everything is shaded underneath it. All right, that is the graphing problem. And the final problem I will leave you with is this. So it's for a party. You can spend no more than $12 on nuts. So whatever you spend can be no more than $12. It means it has to be less than $12 or it could be equal to $12. Okay? Peanuts cost $2 per pound. So let's say 2p. Cashews cost $4 per pound. Those are the two nuts we're buying. What are the three possible combinations of peanuts and cashews you can buy? So there's your equation. Or your inequality, and you can certainly graph it, but you'd have to solve for one of the variables so you can graph it. And I'm going to leave with that. Can you figure out what three possible combinations of peanuts and cashews would work? And that's what I'm going to leave you with. All right, so looking back at our learning target, remember that nice little target I made right there? Think about whether you met that target, you hit that target, or you still need to do a little work with it. Graphing, identifying, and now working with that real world situation. All right, have a great rest of your day.